Welcome you all to dieselship.com. This series of educational videos is presented to you by Sriram. And this video is especially produced by Dieselship Academy. And today we're going to address about the long-lasting doubt whether do we really reverse the exhaust valve cam. Let's watch this video to understand exactly why don't we reverse the exhaust valve cam. So this is a simple diagram which is a timing diagram for two-stroke cross-head marine diesel engine. So with this diagram we're going to understand why the exhaust valve cam need not be reversed. So we all know that the exhaust valve timing is not altered in a MAN BMW MC engine. The reason for that is the exhaust valve timing, as you see from this timing diagram, is symmetric about BDC. Let's see how. Now here is the simple timing diagram. This is the TDC and here is the BDC, which is the top and the bottom dead center. And now let's start with the fuel injection. 10 degrees before TDC the fuel injection starts and the combustion takes place in this area, and the fuel injection stops 15 degrees after TDC, and after that the piston travels from TDC towards BDC, and approximately at 110 degrees to 120 degrees after TDC the exhaust valve opens. The important point over here is the exhaust valve should open before the scavenge ports uncover. So the latest engine, the approximate timing is 110 to 120 degree after TDC the exhaust valve opens, and then the scavenge ports uncover as the piston goes down. The timing is approximately 130 to 150 degrees after TDC, and then the piston goes to BDC. Now at this point the scavenge air, if it's a uniflow scavenging, pushes the exhaust gas out through the exhaust valve and the exhaust manifold, and the fresh air occupies the combustion chamber. And now as the piston ascends up the TDC towards the TDC, the scavenge ports first close approximately 130 to 150 degrees before TDC. Now we are traveling from BDC to TDC. So I always take a reference to mention the crank angle around TDC. So the scavenge ports close approximately 130 to 150 degrees before TDC. If you look at the other side, the scavenge ports open 130 to 150 degrees after TDC. So these two angles cannot be altered, since the scavenge port position cannot be altered. It is same, it's fixed. So the timing cannot be altered. So when we come to the exhaust valve, as the piston slides up, it goes up towards TDC, then the exhaust valve closes, which is approximately again 110 degrees to 120 degrees before TDC. So for an ideal two-stroke cross-head engine, it is the same. The timing diagram as shown over here shows that the exhaust valve opening timing here and the exhaust valve closing timing here is almost symmetric about BDC. So when we reverse an engine, we don't have to alter the exhaust valve timing. So this is a typical exhaust valve cam model. What you see over here is the cam base circle, and here is the peak, and here is the flank. And as you see over here, let's draw the axis through the center. With respect to this axis, the rise and the dwell of the cam is symmetric. The area, the amount of rise and amount of fall over here is symmetric and exactly equal. So if you reverse the engine for the fuel, you need not reverse for the exhaust cam. Let's see how. Now let's assume for ahead direction the engine is rotating in this way, and you have, let's say, a roller on top like this. So the roller is over here and the exhaust valve, the cam should rotate over here. Let's say at this position I stop the engine now, and the exhaust valve has opened fully. If the roller is here, the exhaust valve has opened fully, and now it's starting to close at this position when the engine is running in ahead direction. Now I'm going to reverse the engine. Now I just reverse the engine, the distributor and the fuel cam has reversed, but the exhaust cam, that is this one, has not reversed. Let's see what happens if I start the engine in astern direction, that is this way. Now, since the distributor and the fuel cam has reversed, the engine can be started. Once the air kick is given, the engine starts to rotate. So, in the astern direction, when this starts to rotate, exhaust valve has not opened fully. It is just on its way to open fully. So when this cam rotates in this direction, that is anti-clockwise, the roller slowly goes to the peak and the exhaust valve opens fully and then slides off the dwell of the cam. So which means there is no big difference in the ahead direction and astern direction. Once again, if this is the roller, if the cam is assumed to turn in this direction, that is ahead, the roller has crossed the peak, which means the exhaust valve has opened fully and it is starting to close in ahead direction. But when I start to rotate in astern direction, it is just opened and it has not touched the TDC, or it has not opened fully, which means there is no big difference in the exhaust valve cam timing when the engine is to be reversed. It is for this reason the cam is made symmetric about the axis, and the exhaust valve cam timing adjustment is not carried out during reversing. It all depends on the engine type, but this particular explanation holds good for MAN B&W MC engines. So that's it, and hope you guys have enjoyed this video. For more videos, log on to dieselship.com.